Now that we're done with figuring out the optimal decision strategy, we'll now discuss a couple of important concepts. To do this, we are going to refer to this cleaner picture of the completed tree. The concepts we'll discuss, as shown here, are the risk profile and the expected variable sample information. Remember, the optimal decision strategy was like this. Do the market survey, and if favorable report, then build a large condominium complex. And if unfavorable report, then build a medium condominium complex. Now, so if we follow this strategy, would we make $15.43 million? Well, no. This amount just gives you the weighted average of the possible payoffs. To get a complete picture, what we should do is make a list of the actual payoffs and their probabilities. That is, construct a risk profile. So here's how things are going to go. We're going to do a market research study, and if the report is favorable, then we're going to build a large condominium complex. Now, after that, the demand level will be either strong or weak. If the demand level is strong, then the payoff will be $20 million. If it's weak, it'll be negative $9 million, that is loss of $9 million. So here are the two possible payoffs. Now, if the report is unfavorable, then we would build a medium condominium complex. And if the demand level is strong, then the payoff will be $14 million. If the demand is weak, then the payoff will be $5 million. So that's it. So these are the four possible payoff values. Now let's list them in a table in increasing order. So we're going to build a table here. Payoffs and the probabilities. So it's -9, 5, just going in order, 14, and 20. Now, what are the probabilities associated with these payoffs? Well, let's see. To get to -9, starting at node 1, we have to go this way, and this way, and this way. So to get to the payoff of -9, two things must have occurred. A favorable report and a weak demand. So here we want the probability that favorable report and weak demand S2 have occurred. So this is joint probability. So you know that you need to multiply the corresponding probabilities. Formally, we'd be doing something like this. We'd be going probability of favorable report, and then after that, given the favorable report, getting the weak demand. So that is S2 given a favorable report. And now these probabilities are 0.77 and 0.06. So we just multiply these together. 0.77 times 0.06. So that gives us 0.05, 5% of losing $9 million. And we proceed in a similar way for the other three payoffs. So 5, to get to 5, from the here, unfavorable report must have occurred. And then after that, given unfavorable report, weak demand must have occurred. So that's going to be unfavorable report and weak demand. So we multiply the corresponding probabilities. That's equal to 0.03 multiplied by 0.65. That gives us 15%. For the 14, it's going to be 0.23 times 0.35, 0.08, and 20 is over here. The probabilities are 0.77 times 0.94. That gives us 0.72. So this is the risk profile. We have 4 possible payoffs, and here are the probabilities. So this is what would actually happen if we go with this highlighted optimal decision strategy. Now we could see that if we add up these probabilities, we should get 100%. So let's see, sum these probabilities, giving us 1, giving us 100%. So, that makes sense. Now let's compare this to not doing the research. If we don't do the research, we would just build large condominium complex, and that will give us either 2 on year of -9 and with these probabilities. We actually built the risk profile for this case before over here. Oh, it's all right over here. So I'm gonna just copy this over to next to the newer risk profile over here. Okay. So you can see that doing the market research does lower the risk. Take a look at the probability of losing $9 million. And now here, without doing the research, there's 20% chance of losing $9 million. But if we do the market research, the probability of losing $9 million is reduced to only 5%. So we could see this strategy is, besides being optimal in terms of getting the higher expected value, it also comes with a lower risk level. Okay, now let's talk about the value of this market research study. From the analysis we've done, we know that when the cost of market research is $500,000, that is, 0.5 million, it will be worthwhile to do it. Now, what if it costs more? For instance, what if it costs, let's say, $2 million, like this? Then the net here will be 15.93 minus 2 is 13.93 million. Now, this value is less than 14.2, so we would not do the research. You would go the other way. In general, the question is, where is the price point at which it's no longer worthwhile to do the research? That's when the value at node 2, minus the new cost is less than the value at node 5. In other words, when the new cost is higher than the difference between the value at node 2 and the value at node 5. So we would say we would not want to pay more than the difference between the node values here. That difference is the value of the market research, and it's called the expected value of sample information, or EVSI for short. The formula here is EVSI is equal to EV with SI minus EV without SI. That is expected value if you conduct the research minus the expected value if you don't conduct the research. So in this case, it is 15.93 right here minus 14.2, which is this term, and that's going to be equal to $1.73 million. And so the EVSI of $1.73 million is the maximum we're willing to pay for the market research. So if the market research costs anywhere above this amount, then we would choose not to do it. The concept is similar to EVPI, the expected value of perfect information, but this time the information is not perfect. We call this information sample information, because in most cases, the information is obtained by sampling. That is, we might survey a sample of customers to gauge their interest in the product. So in summary, we could compute the EVSI by taking the difference between the top node value and the bottom node value. Remember, the first term is the node 2 value before subtracting the cost.